Hello students, myself Deepak Kudva, Physics faculty, Shakthi PU College, Shakthi Nagara, Mangalore. So today we are going to deal with the very interesting chapter in physics, that is mechanical properties of solids. First we'll see what is solid. As soon as from the high school section we have seen that the solid in the sense of whichever have a definite shape and volume, correct? Whichever have a definite shape and volume is called a solid. Now whether every solid has its mechanical property, whether it has any physical properties. Yes, it has some physical property, and yes, it has some mechanical property. Then what are these mechanical properties? We'll see. So the mechanical properties are mainly divided into two types. One is elasticity. Second one is plasticity. Now we'll see what is elasticity and what is plasticity in detail. Very simple one. Elastic. And every one of you know that what is elastic. What are elastic bodies? Very simple one. Let us take this rubber band. As soon as you see this rubber band, we say that it's an elastic body. How can we say that's an elastic body? Very simple one, right? When you stretch this, it will change its shape. When you release the force, it can regain the shape. This is called as elastic body. Very simple one, correct? What is elastic body? When you stretch the body, it changes the shape. When you release the body, it can regain the shape. That is called elasticity, where it can regain the shape. When you come to plasticity, where it cannot regain the shape. Is called a plastic body, correct? So now to regain the shape or to change the shape, there's some force have to be applied, correct? So that force is called deforming force. Deforming means changing the shape. Now this is the elastic body. Now imagine that this is the rigid support. This finger is a rigid support. Now I'm going to apply force in this direction. That means as soon as you apply the force, what happens? The body changes its direction in the direction of deforming force, correct? Now this is the deforming force. The body changes its length, correct? So that means when you release the deforming force, the body will regain the shape, correct? So that means we'll imagine this is the elastic body. This is my rubber band. Now I'm going to apply the deforming force in this direction. This is the deforming force. Clear? This is the deforming force. Now to change the shape, we need deforming force. To regain the shape, what we need? There should be some other force acting internally, correct? To change the shape, we need deforming force. To regain the shape, we need some other internal force, correct? That is developed by the solid itself. That is nothing but that is restoring force. That is restoring force. That is acting in an opposite direction to the deforming force. Because of this restoring force only, the body can regain the shape. Now we can ask one question. What happens in the plasticity then? Here, imagine that this is a plastic body. Correct? No? This is of course a plastic body. This pen is a plastic body. Now, I need to change the shape. So what I can do, imagine that I am going to heat this, the plastic. Correct? I am going to heat this and I am going to apply the deforming force in this direction. Now I am going to cool this. Once you cool this, can the body regain the shape? No, the body cannot regain the shape. That's what we call it as a plastic body, where the body cannot regain the original shape. That is called plastic body. Clear? Understood? Yes, next one. In this elastic body, we have something called elastic limit. We'll see what is this elastic limit. Elastic limit is nothing but it's a upper limit. We call it as a upper limit. Elastic limit. So this is nothing but it's a upper limit. Now for example, again we'll take this rubber band. We'll consider this as an example. Now when I'm going to stretch this, it has got some limit, correct? Beyond this, where the body cannot stretch, that is called as a elastic limit. Where the body cannot be further stretched is called a elastic limit. Simple keyword to remember the elastic limit, that is, it is a upper limit. Upper limit in the sense that's a maximum limit. We call it as maximum limit where the beyond the body cannot be stretched at all. If you go beyond this, then what happens? If you go beyond the elastic limit, what happens? The body undergoes for the plasticity. Clear? Understood? In the plasticity, we don't have any elastic limit. Remember that. Okay? So now, elastic limit. We understood that elasticity is a property of the material. Remember that elasticity is the property of the material. Property of material. Okay. Why we call it as the elasticity of the property of material? I will imagine that this is a rubber band. This is a small rubber band. Correct? No? I'll use the same material. But I'll use some big one. Clear? Understood? I'm going to use some big one. But the elasticity will be same, right? Because it depends on the nature of the material. Now imagine now this is a rubber band. I'm going to use the one more as a stainless steel. So it may have the different elastic limit. Clear? That's what we call it as a elasticity, which depends on the property of the material. The next concept is stress. We'll see now what is stress. Very simple one. Stress is nothing but it is like the pressure itself. Stress is force per unit area. Force per unit area is called a stress. Very simple one. Now to change this has got an area. Correct? This has got some surface area. Now what I'm going to do? I'm going to apply force in this. As we apply the force, what happens? The area changes. That is nothing but that's called as a stress. So this force can be equal to deforming force by area, which will be equal to restoring force. By area. Why deforming force equal to restoring force? We'll see. The amount of deforming force you applied, the same amount of restoring force is created in the opposite direction. So that's why we are going to call it as a stress is nothing but force per unit area. Force per unit area is nothing but that is stress. Force per unit area. Now, can you tell me the SI unit of this? Can you just guess the SI unit of this? Yes, the SI unit is very easy, correct? What's the SI unit of force? The force is Newton. What's the SI unit of area? That will be meter square or Newton meter square. We can write like this also. Correct? No? One more. To look this, this looks like a pressure. Correct? No? Force by area is nothing but it's like a pressure also. What's the SI unit of pressure? Yes, that is Pascal. We can write it as a Pascal also. Now, we can write the dimensional formula. Can anyone guess the dimensional formula? So, the dimensional formula, very easy. How to write the dimensional formula? So, that is Newton. Newton means what? Force per unit area. Correct, no? Force by area. We'll see. We'll write the dimensional formula. That will be force is nothing but mass into acceleration. And the area is nothing but that is meter. Correct? Meter square I can write. Now, what's the dimensional formula of the mass? Mass is m1 and the acceleration is L1 t to the power minus 2 divided by dimensional formula of the area is L square. Now, what will be the answer? Dimensional formula will be m1 L to the power minus 2 goes up. That will be L to the power minus 2. So, answer will be L to the power minus 1 t to the power minus 2 is the dimensional formula of the stress. Understood? So the next one, this stress is divided into several types. Clear? Stress is divided into several types. That is, first one we'll see. Stress. 3 types are there. Okay, mainly 3 types. So the first one is longitudinal. First one is longitudinal or normal stress. First one is longitudinal or normal stress. Second one is bulk or volume. Bulk or volume. The third one, another name for this is hydraulic. We call it as a hydraulic also. So the third one is shear. Shear or tangential. Tangential. Clear? Now further, this longitudinal is divided into 2 types. First one is tensile. First one is tensile. Second one is compressive. Second one is compressive. Now we'll see what is longitudinal first. Remember one thing, solid means mainly it depends on a shape. See, here we are going to speak about the three configuration. One is in terms of length, in terms of volume, and in terms of shape. Clear? Three configurations we are going to speak now. Entire chapter deals with only three configurations. We'll see now what happens. So the first one, the longitudinal or the normal. Very simple one. Normal in the sense we know that normal is nothing but that is 90 degree, which is acting perpendicularly. Correct? Now, if I want to change the shape of this, correct? What I have to do, I have to apply force in this direction. That means acting normally on a body, perpendicularly on a body. When the force acts perpendicularly on a body, that is called a normal or the longitudinal stress. Very simple one. Normal means that is perpendicular. Remember the keyword, okay? When the force acts normally or perpendicularly on a body is called a longitudinal or normal stress. Now imagine the rigid support is in this direction. If you want to change the direction, if you want to change the shape in this direction, means you're going to act the force in this direction. Correct? So this is called as a longitudinal or the normal. Imagine the force should be here. That means this is acting normally. Clear? This is longitudinal or normal stress. Next one, tensile. We'll see the tensile one. Very simple one. Tensile means if the length increases. If the length increases, that is called tensile stress. Clear? Now, here the force is increasing. I'm applying the force in this direction. That means length is increasing. The length is increasing in the direction of deforming force. This is called tensile. Very simple one. If the length increases, that is called tensile. If the length decreases, then it is called compressive. Okay, understood? If the length increases, that is called tensile. If the length decreases, then it is called compressive. Very simple one. Okay, remember the keywords. If the length increases, if the length decreases, then it is called compressive. Clear? Understood the students? Next one, we'll go for the next concept, that is bulk. We'll understand what is this bulk. Bulk in the sense volume. Correct? We are going to take it as a volume. Now imagine that you people know about the sponge ball. Kind of with that smiley we have, no? Yeah, the sponge ball. Now imagine that you're going to hold that sponge ball. When you squeeze that, what happens? The volume changes. Correct? Now imagine this is our sponge ball. Clear? I'm going to apply force from all the direction. From all the direction I'm going to squeeze it. As soon as you squeeze that, what happens? The radius decreases. Correct? No? So initially I can take this is V, and this one I can take it as this change in volume can be taken as delta V. Why? That means V is nothing but sphere, no? The volume in the ball in the shape of sphere. So volume formula will be 4 by 3 pi r cube is the formula. What is going to change here? The radius is changing here. Correct? If the radius changes, then the volume also changes. This is called as a bulk or the volume stress. Okay? In the first one, the length changes. Longitudinal, the length changes. In the second one, the volume changes. Then what about the third one? Of course, 100%. Length is done, volume is done. Then what remains now? That is shape. If the shape changes, then it's called tangential or the shear stress. Okay? Very simple one. Now you take one cylinder. We're going to consider one cylinder. Okay? Imagine that this is the rigid support. It is attached to the rigid support. So here tangentially, what do you mean by tangentially? Touching one point. Clear? Tangent means which touches the one point. Now remember that the force is applied to the top face. Okay, I'm going to apply force to the top face. That means I'm going to pull this. This is a rigid support. Remember that this is the rigid support. I'm going to apply force in this direction. As you apply the force in this direction, what happens? Of course, the lower part is fixed. Lower part is fixed and the upper part is going to displace. Correct? No? This is the upper part. That means it makes one angle here. That is the theta. This is what we call it as a shear or the tangential stress. Hope everyone understood this. So first one is longitudinal. Longitudinal in the sense what? The force acting perpendicularly. The force acting perpendicularly is called longitudinal or normal. That is divided into two types. One is tensile, second one is compressive. Tensile means if the length increases, that is called tensile stress. If the length decreases, then it is called compressive stress. So next one is bulk. It mainly deals with the volume. Clear? That means the force is acting from all the direction. Clear? That's called volumetric or the bulk stress. Next one is shear, which changes in terms of shape. That means the force is applied to the top face tangentially on the body. It's called a shear or the tangential stress. Clear? And the next concept is, that is strain. Okay, very important two concepts. That is stress and the strain. Now we'll understand what is strain. See, stress means we are going to deal with the force. We are going to deal only with the amount of force applied. But strain, which deals with the change in configuration. Clear? Now we took here. Let me take this rubber band. Yes, we take this rubber band. See, now stress means the amount of force applied on this. Clear? But in this stress concept, we are not worried about the change in configuration. With what amount the length changed, we are not worried. But here in strain, we are going to check what amount of the value changed or what amount of length changed according to the original length. That is called a strain. Clear? Strain is nothing but that is change in configuration. Change in configuration to the original configuration. Original configuration. Now what is this configuration? What do you mean by configuration? So the mechanical property mainly deals with the three configurations. Correct? One is in terms of length, in terms of volume, and in terms of shape. If any one changes, then that is nothing but that's a strain. Now imagine that I'll take one. Okay, take one rubber length, one conductor. Okay, one rubber band. We'll imagine that the length is L. Okay, this length is L. I'll take it as a length L1. Now the deforming force is acting in this direction. Deforming force is acting in this direction. So when you apply the deforming force in this direction, what happens? The shape changes. Correct? No? This is the shape. This is the extra length. So this one I can take it as a delta L. Change in length. Clear? And this one I can take it as L2. So now delta L is nothing but that is L2 minus L1. If you minus L2 with respect to L1, what we get? We get a delta L. Clear? So that means change in configuration. What is changed here? The length change to the original configuration is called a strain. This strain is divided into three types. So the first one is tensile strain. First one is tensile or normal strain. Normal strain, or else one more name is longitudinal strain also possible. So now the tensile and the normal, in a sense, which deals only in terms of length. Which deals only in terms of length is called tensile or the normal strain. So that can be taken as a delta L by L. Delta L by L. Change in length to the original length. What's the original length here? Original length is L1. Correct? Or you can take it as a L also you can take. Clear now? Understood? Original length you can take it as L. Understood? Delta L by L is nothing but that's a tensile or the normal strain. And remember one thing, strain is a dimensionless. Strain is a strain is a dimensionless, okay? Dimensionless. Understood? So now, second type. We are going to take up the second type. So the second type is bulk. Bulk or volume or hydraulic. Bulk or the volume or hydraulic. Very simple one. Let me take one example. I'm going to take one tub. Okay. In this I'll fill the water. I'll take one balloon which is spherical in shape. Clear? It has some volume, right? What's the volume? What's the formula? 4 by 3 pi r cube I'll take. Clear? I'll dip this balloon inside the water. Inside this tub. What happens to the balloon? Of course, the balloon should come up. Clear? Balloon will come up because of the density. Now here, what happens? Just think now. The size of the balloon decreases. Of course, the size of the balloon should decrease. Why? Because the hydrostatic force is acting upon the surface. This, what does the water does? This will apply force from all the directions. Clear? the water, that's what the hydrostatic force will be applied on the balloon from all the direction. That's what we call it as a bulk volume or the hydraulic. You can take the example of the sponge balloon also. We can take it as a volume V. When you apply force from all the direction, what happens? The radius decreases. Correct? No? The radius decreases. This change in volume can be taken as delta V. So that means bulk or the hydraulic is nothing but that is delta V by V we can take. Even this is also the dimensionless quantity. Understood? Yes. Next one. We'll go for the third one, that is shear. Shear or shearing we call. Shear or shearing strain. Okay. So now shear and the shearing strain mainly deals with the shape. Okay, now imagine that you have one container, okay, which is cylindrical in shape. It is supported, okay, this is fixed to the rigid support. Now I am going to apply force in this direction. I am going to apply force in this direction. That means the top face is displaced, correct? No, the top face is displaced. So it makes one angle here. This is theta. Clear? So initially I can take this as a L, and this displacement I can take it as a delta L. Clear? That means theta is not nothing but, or else usually we are going to take it as a tan theta. Tan theta is nothing but that is delta L by L. Tan theta is equal to delta L by L we get. You know the trigonometric function, correct? Now imagine that when the shape changes, it won't be in terms of 30 degree, 40 degree and all, correct? 45 degree. So the changes might be in a small degree also, correct? Now imagine that if theta is small, then tan theta is approximately almost equal to theta. We can take it as theta is equal to delta L by L also we can consider. Understood? These are the three types of strain. What are the types of strain? So the first one is tensile or the normal strain. The second one is bulk volume or the hydraulic strain. The third one is shearing. So here the tensile mainly deals with the length, bulk volume or the hydraulic deals with the volume, and the third one deals with the shape. In today's class, we have seen the concepts of stress. We have seen the types of stress also. The stress is mainly divided into three types. One is longitudinal stress, bulk stress and the shear stress. And that longitudinal is divided into two types. One is tensile and the compressive. So the next concept we have seen, that is strain. Strain means that is change in configuration to the original configuration. Configuration means mainly length, volume and the shape. And that strain is further divided into three types. One is tensile or the normal strain. Second one is bulk volume or the hydraulic strain. Third one is shear or the shearing strain. In the next class, we'll see the concept of Hooke's law. Very, very important concept. Thank you.